Hello everyone. Here we have our topic 2 ticket to retake. So if you are interested in retaking your topic 2 test, this video is just here to help support you guys as you work through a little bit more practice to get you ready for a retake. All right, so number 1, graph the equation y equals negative 5x plus 1. One thing I want to notice, or what I want us all to notice and to point out, is this is in slope-intercept form. This is in the form y equals mx plus b. When it looks like this, it is ready for us to graph. We can identify the slope of our line. So m is the slope, it is the number with the x, so we have a slope of negative 5. And then our b is the y-intercept, and that's the ordered pair 0, 1 on the y-axis. So when we graph a line, we always need to start with plotting a point on your graph, and from there you can do your slope. So we're going to plot a point at a positive 1 on the y-axis. So just be careful. This one is the y-axis, this one is the x. Sometimes we plot it on the wrong axis, so you just want to double check that. And then our slope is negative 5. You can write your slope as a negative 5 over 1, so you can see the rise over the run. And what we're going to do is we're going to go to our starting point, the y-intercept. We're going to go down 5, 1, 2, 3, 4, 5, and we're going to run 1 to the right. You want to run to the right. If you notice, that's going to get us a downhill line. If I run to the left by accident, I'm creating an uphill line, but I know that our slope is negative, so this should be downhill. So we're going to go down 5 to the right 1. I would go down 5 to the right 1 again, but that takes us off the graph. So then I'm going to go back to the y-intercept and I'm going to retrace those steps. I'm going to go up 1, 2, 3, 4, 5, and to the left. I think I said retrace those steps. I meant you're just going to work backwards now. All right, and now we will draw the line that crosses through those points. All right, so that's graphing from slope-intercept form. Number 2, write an equation of a line in slope-intercept form. So there's that y equals mx plus b that passes through 3, 4, and 5, negative 2. So in order to write the equation of this line, we need to know two things, the slope of our line and the y-intercept of our line. We were not given the slope, and if I look at these two ordered pairs, neither one of these is the y-intercept, so we don't know anything about our line. But we do know 2 points that our line goes through. So what that's going to help us out with is finding the slope. I'm going to label the points x1, y1, x2, y2. We do have a slope formula. M equals y2 minus y1 is the change in your y's over x2 minus x1, the change in your x's. So y2 minus y1, negative 2 minus 4 over x2 minus x1, 5 minus 3. Negative 2 minus 4 is negative 6. 5 minus 3 is 2. So we have a slope of negative 3. So now we can start writing our equation. We know we have y equals mx. Well, we just figured out our slope of m is negative 3x, and then plus our y-intercept. We did point out that we looked at our two ordered pairs. Those are not on the y-axis if you were to plot those. So I'm just going to leave this as plus b. I changed my b into a capital B because otherwise it looks like a 6 and I don't want to confuse anyone. All right, so how do we get that y-intercept? What we want to remember is that the equation of the line contains a bunch of points, and any point that's on the line, here we have 2 points that's on the line, will work in this equation. So what we can do is we can grab one of the points, whichever one looks easier, maybe this 3, 4, I think that looks a little bit easier to use, and you can use that as a helper point. You can plug in the 3, 4 for the x and the y in our equation, and that will allow us to solve for b. So this y equals, I'm going to replace the y with the y from our ordered pair, which is a 4, equals Negative 3 times the x from that ordered pair is 3. As long as I'm using the same, pulling from the same ordered pair, like I'm just using one ordered pair. I didn't use that 5, negative 2 to help me get the y-intercept. All right, plus b. Next, we'll just multiply this together. We have a negative 9 plus b, and then our last step is to add 9 to both sides. So we have 13 equals b. So now we know our y-intercept is b. So we know what number goes right there. So we've got our final equation we can write. Y equals mx, negative 3x, plus b, or b is a positive 13, so plus 13. There's the equation of our line in slope-intercept form. All right, number 3. What is the equation of a vertical line that passes through negative 3, 4? So I am a very visual person. I like to draw these out. Here's my coordinate plane. And it says that it's a vertical line. That's some key information. And the vertical line, is going to look like this, right? So the question is where, I know what a vertical line looks like, so where do we put it? And it does want to go through that ordered pair, negative 3, 4. So I'm just going to plot that. Negative 3 would go to the left 3. Positive 4 would go up 4. So negative 3, 4 to left 3, up 4. That's where the vertical line has to go. It's going to go through that point. So I'm going to go ahead and draw a point, or draw the vertical line through that point. That is our vertical line. Now, these are very special lines. A vertical line and a horizontal line, their equations are super basic. You're going to have one variable and one number, and that's it. Either x equals a number or y equals a number. If we look at this line, how do we know if it should be x equals or y equals? Well, that depends on the axis that our line passed through. So here's our vertical line. See how it crosses through this axis? So this is the x-axis. So our equation is going to be x equals, and then where did it cross through the x-axis? What is this spot right here? 1, 2, 3 to the left. So that is going to be a negative 3. X equals negative 3 is the equation of that vertical line. If we were to write out ordered pairs on this line, every single ordered pair would have an x value of negative 3. We're going 3 to the left, then up or down to get to any point on that line. So that's all we have to write for our equation is x equals negative 3, because every single point on the line has an x coordinate of negative 3. All right, so number 4, we can approach very similarly, only this time we want to figure out what the horizontal line is that passes through the point 3, negative 5. So again, let's sketch this out just so we can make sure we understand what we're seeing. So again, a horizontal line, that would be some key information to pay attention to. Horizontal lines go like this. So I can draw in a horizontal line anywhere, but where do they want us to draw in the horizontal line? Through the point 3, negative 5. So let's plot that point. 3, negative 5 from the origin goes to the right 3 and down 5. So if I go to the right 3, down 5, there's the line, or that's the ordered pair that our vertical line goes through. And so now we're just going to draw a vertical line. And did you guys notice I'm drawing vertical and it said horizontal? So let me change that. So it's a horizontal line, I'm so sorry, that goes through this point. So let's draw in a horizontal line. There we go. All right, so this horizontal line is crossing through the y-axis. So it's going to be y equals. And it's crossing through the y-axis at a negative 5. So y equals negative 5 is the equation of that horizontal line. All right, number 5, graph this line 4x minus 12y equals negative 24. What I want us to notice here is that this is not slope-intercept form. It's not y equals mx plus b. So as I look at this equation, none of these numbers are going to be, we're not going to graph a 4, 12, or a 24. You have two ways that you could graph this. You could solve this for y. If you solve this for y and get it into slope-intercept form, then you can graph it like the first problem on this page. But I do want to show you another way. This is standard form, ax plus by equals c. So how can you graph when you're given standard form? And we can graph using x and y intercepts. So our x-intercept, let's find that first. That's going to be where our line crosses the x-axis. X-intercept we find by plugging in a 0 for the y. So I'm going to say 4x, and then I'm just going to, if I plug in a 0 for this y, negative 12 times 0 is 0, so this whole term cancels out, leaving us with just our equals negative 24. So I'm just going to jump to equals negative 24. We just talked through why the y coordinate is no longer there. Let's divide by 4, so we get x equals negative 6. And then that, as an ordered pair, the x-intercept is a negative 6 for the x, and we plugged in a 0 for the y. Now let's do the same thing, but let's find the y-intercept. As long as I have 2 points on my line, then we can graph a line. And the reason why it's a quick way to do this is by finding intercepts. When you find an intercept, you plug in a 0 for your variable. And when we plug in a 0, things cancel away on us, and it just makes it easier to solve for the other variable. So finding your intercepts are two pretty convenient points you can find on your line. All right, so a y-intercept tells us to plug in a 0 for the x, so 4 times 0 is 0. This whole term cancels away, leaving us with this negative 12y equals negative 24. We're going to solve for y by dividing both sides by negative 12. So we get y equals a positive 2. And this intercept, as an ordered pair, we plugged in a 0 for the x, and we got back a 2 for the y. All right, so plotting these points, the y-intercept 0, 2 is on the y-axis at a positive 2, and then the x-intercept is negative 6, 0. So let's add a negative 6 on the x-axis, and now that I have 2 points on the line, I can just go ahead and draw the line through those. All right, number 6, what is the equation in point-slope form of the given line? And it says use the point 6, 1. All right, so point-slope form, we've not talked about that yet. Point-slope form is y minus y1 equals m times x minus x1. To write this equation, all you need is the slope of your line and 1 point on your line. So here's the point they want us to use. If I look at the graph, 6, 1, over 6 up 1, that's where that ordered pair is. So that 6, 1 gives us the x1 and y1 that we're going to use here and here. And so what we need is the slope. We could pick out 2 ordered pairs and do our slope formula. But because we're presented with a graph, it is okay to count your rise over your run. So when you count the rise over the run from a graph, you want to start with a point on the left and go to a point on the right. So maybe I would start with this point right here. Doing the rise first, are we going to rise up or rise down to get to the point on the right? We're going to rise down 1, 2 units just until we're in line with that other point. Because we went down 2, that's going to be a negative 2. Then we're going to run 1, 2, 3. And when we run to the right, that is a positive 3. So this slope, rise over run, is negative 2 over 3. All right, so now we can go ahead and write our point slope form. We have y minus y1 is the y coordinate of this point, so a 1, equals our slope, negative 2/3 times x minus, and then x1 is this 6 from the ordered pair, and that is point slope form. There is no solving for anything when you do point slope form. All right, number 7, what is the equation in point slope form with a line that passes through these 2 points? So again, point slope form, y minus y1 equals m times x minus x1. What do we need to know about our line? We need to know a point on the line. So here's x1, y1. We can use that point, and we also need the slope. I'm going to go ahead and label the other points x2, y2. If we don't have the slope, that's the first thing we need when we write an equation of a line. So we don't know what our m is, but we have an equation. Slope is equal to the change in your y's, so y2 minus y1, over the change in your x's, x2 minus x1. And then we'll just plug in the numbers. Y2 is 3 minus, our y1 is a negative 2. So when you minus a negative, it turns to a positive 2. Over x2, 5, minus x1 is a negative 3, so minus a negative turns into positive 3. All right, 3 plus 2 is 5, 5 plus 3 is 8, so our slope is 5/8. So we have our slope, we have our x1, y1, and now we're just going to plug this into point slope form. So y minus y1 is a negative 2, so minus a negative 2 turns into plus 2, equals m, our slope is 5/8 times x minus x1, which is a negative 3, so minus a negative 3 turns into plus 3, and there's point slope form. All right, number 8, find the y-intercept of the line. There are 2 ways to do this. Anytime I'm going to show you both ways, and you can tell me what way you like better. Anytime that you have to find an intercept, you can plug in a 0 for the other variable. So to find a y-intercept, you can plug in 0 for x. Here's what that would look like. Y plus 6 equals negative 2 times 0 plus 4.5. And then we just simplify. Y plus 6 equals negative 2 times 0 plus 4.5 is 4.5. Y plus 6 equals negative 2 times 4.5 is a negative 9. And then we'll just solve for y by subtracting 6. So we get y equals negative 15. So our y-intercept is the ordered pair 0, negative 15. All right, the other way to do this is if you want to know the y-intercept of a line, we remember that y equals mx plus b. That's your b value. The y-intercept is b. So we could take our equation and solve it for y so that we have mx plus b, and then we can identify our y-intercept just right from our equation. So what that would look like is we have y plus 6 equals negative 2 times x plus 4.5. We're going to start by distributing the negative 2. So y plus 6 equals negative 2x. Negative 2 times 4.5 is a negative 9. And then we will subtract 6. So y equals negative 2x. Negative 6 minus 9 is negative 15. And now we can see y equals mx plus b. Our b value is negative 15, giving us 0, negative 15 as a y-intercept from this equation. So 2 ways to do it. Pick your favorite one.